Ciao friends, and welcome to a new video from SQLBI. In this video, I want to talk about real-time dashboards and push datasets, introducing a tool that SQLBI recently published that make it easier to create push datasets. But first things first, what is a real-time dashboard? It is a dashboard that updates in real time. Let me show you an example of this. As you can see, we have a dashboard, which is not really a cool dashboard. I'm totally not good at building dashboards, but it has the interesting feature that it updates its values continuously. You see that the numbers change without any human touching the keyboard or doing anything, because this is a real-time dashboard that detects changes in the database and updates its content based on the latest data that is available in the database. This is the kind of dashboard that you are likely to create and use, for example, in the whole of an office to show the sales of today, or the number of open tickets, or the number of tickets that you have been servicing during the day, kind of information that are useful to see in real time. Creating real-time dashboards is kind of a complex topic because Power BI with the Vertipack store is not designed to create real-time dashboards. Power BI, if you use Vertipack, is designed to work in pull mode, meaning that the database, the model at data refresh will pull data from the database, populate its internal Vertipack store, and then all the reports are created based on the Vertipack store. The Vertipack store is updated as of the last data refresh, so you do not have real time if you are working in import mode, which is the default way of working of Power BI. If you need real time, well, the first technology that comes to the mind is DirectQuery. You could use DirectQuery, and DirectQuery is real-time. With DirectQuery, whenever you run a DAX query, that query hits the original data source, so you always have the latest information available. The thing is, DirectQuery provides you real-time, but it also comes with limitations and problems. Performance is the first problem you need to face. Let's face it, DirectQuery is slower than Vertipack. Then from the DAX point of view, you have some limitations. And if the entire model is designed using DirectQuery, then you will have to find a modeling workaround in order to overcome these limitations. And the entire development of the model is quite a problem. Besides, is it really worth moving the entire solution in DirectQuery just to build one real-time dashboard? Because again, it's unlikely that your entire data model needs to be real-time. If you have 10, 100 reports as part of your overall solution, then maybe 1, 2 dashboards need to be real-time. The remaining part of the project can work in a regular import mode, because when you analyze the sales of the last 10 years, it is not really relevant what is happening today. So some dashboards require real-time, while the vast majority of your dashboards and reports do not need it. That is why there is a better alternative to moving the entire project to DirectQuery, which is using push datasets. Push datasets work in a very different way if you compare them with Vertipack models. A Vertipack model works in pull mode, meaning that at data refresh time, the model pulls data from the database, populates Vertipack, and then it starts answering to queries. And until you send another refresh, the model stays as it is. Push datasets are very different. A push dataset just sits there waiting. It has its own database, but the database by default is empty, and the data model doesn't do anything. So Power BI will not do anything, just sit there waiting until somebody pushes data inside it. So Power BI is there waiting for data to arrive, and as soon as data arrives, it is inserted into the database of the push data model, and all the dashboards which are linked to the database are refreshed to update the new data. The technology is very different, and it's not new at all. It has been there for a long while, and it has not been used very widely. The reason is push datasets are different in their implementation, but they are also different in the way you create push datasets. You cannot create a push dataset just by creating a Power BI desktop file and uploading it to the service, because the technology is different. A push dataset handles all the interactions through REST API. So if you want to create a model, a push dataset, you cannot just create it with Power BI Desktop. You need to create it through the REST API. So you need to call an API to generate the model. And the same for pushing data. If you want to push data inside the push dataset, you need again to call a REST API to send data. And then there are some limitations, not too strict, but there are some limitations for push datasets. The interesting thing is that we recently published a tool that makes it easier to create push dataset. So what we could do is think about a different architecture. Instead of moving the entire solution to DirectQuery, what we can do is build the entire solution using import mode, the default, safest and fastest way of developing your tabular solution. And then we pair it with a push dataset whose only goal is to serve the real-time dashboard. And the tool helps you in creating this push dataset out of the original import model. Let me show you this with a couple of diagrams. Here on the screen we have the architecture of a regular Power BI model. We have the Power BI dataset here. And the Power BI dataset loads data from a database running SQL queries, and the database is populated from the OLTP system. The problem is that this step happens during data refresh. We have data refresh operations, and data refresh happens once a day, typically once a day. It might be more frequent. But this means that the data that is seen from this part of the architecture that contains reports and dashboards can only access data which is 1 day old. You never have real time. By using push dataset, you rely on a different architecture. We will pair the currently existing model with a new model that is a push dataset. Let me show you this. The architecture with a push dataset is slightly different. The bottom part is the same, but then we add this part, the Power BI push dataset. This is a model that serves the purpose of being real-time and provide information to real-time reports and real-time dashboards. Remember, not all of your dashboards need to be real-time. Not all of your reports need to be real-time. So you need to identify where real-time is needed and where it is not. And once that happens, you build your push dataset. The push dataset can be created as a copy of the original import model. Then, as we said, a push dataset sits there. It is empty at the beginning. That is why you need to have, let me clear this a bit. You need to have these operations. Whenever a new row enters into the system, you need to move the row from the OLTP inside the push dataset. And this requires developing some code that sends the information from the OLTP system inside the push dataset. Then we have another detail that we need to worry about. As we said, the push dataset starts empty. Therefore, it does not contain any data. And if you load data from the OLTP system, you will end up loading a lot of information inside the push dataset. And push datasets are not designed to contain huge amount of data. Therefore, you typically have a push dataset that starts empty at the beginning of the day, and it contains data for the day, so the OLTP system sends information only for the current day. What if the dashboard does not rely only on data of today? Maybe you need to make a comparison between the previous month and the current month, or the previous year and the current day, or you need some statistical information that can be gathered only by accessing historical data. Therefore, in your push dataset, you will need to have not only the data of today, but also some data from historical data. That is why the entire architecture is designed in a slightly different way. We have the push dataset that, as we said, starts empty, but then at the beginning of the day we run a script, a DAX script that loads data from the Power BI dataset and uses it to populate the push dataset. So this is the overall flow of the system. We create one push dataset that starts empty. At the beginning of every day we empty it, and then we load it with the historical data that is needed to populate the dashboard. Then during the day, the OLTP system sends new information to the push dataset so that the push dataset stays up to date with the data of today. Doing this, you have two different models, with the advantage that the historical model, the real model, only relies on import mode, so it's easier, faster. It's the standard way of developing tabular models. Whereas the real-time dashboards, they are based on a push dataset which is emptied at the beginning of the day, initialized with the data, the historical data that is needed, and then it is ready to receive new information. This is where the tools that we are publishing comes as helpful, because you can use these tools to take the Model.bim file, the description of your model, and create a push dataset out of it. The tool does a lot of small operations that are rather important. First of all, it checks that your model obeys the rules of push dataset. There are some limitations in the way you can write DAX code and in the features that you can use. Nothing complex, nothing hard, but there are some limitations. So the tool will take Model.bim and check that it is compatible with a push dataset. Then it has the option of publishing the model. So it takes the Model.bim once it complies with the limitation of a push dataset, and it gives you the option of creating the push dataset. Then, again, the set of tools that we are showing also give you the option of running the DAX queries that we have seen earlier. This update script, so the set of DAX queries that are needed in order to populate the push dataset at the beginning. You need to write those DAX queries the right way, because you cannot just take the entire model and dump it inside the push dataset. There are limitations in the number of rows, so you need to reduce the number of rows in the push dataset to a number that works with the specific push dataset you are creating. And finally, the tool also provides you a demo mode that gives you the option of pushing data inside your push dataset using random values. This is extremely useful whenever you want to build a POC to demonstrate the technology to somebody. Let me show you some more details about that. We can go back here and first of all, how do you retrieve the Model.bim? Because we said you need to use Model.bim. And what is Model.bim? Well, Model.bim is the description of a model. Here we have a regular Power BI file that contains some tables with their own diagram, and this is a regular import mode. If you want to move this to a push dataset, you need to extract Model.bim. And there are no ways you can do that from inside Power BI. But you can use a Tabular Editor. You launch Tabular Editor, Here it is. And Tabular Editor gives you the option of looking at Model.bim, but most importantly, it lets you save Model.bim. We can call this push dataset. And then we can just inspect it. Let me just open it with Visual Studio Code. And you see that the result is a JSON file that contains the complete description of your model. It's not important now to understand the details about Model.bim. What is important is that you can extract Model.bim from any Power BI desktop file. Once you have your Model.bim, you can run the tool. But before running the tool, you need to download it. That's why I think that I forgot to show you. If you want to download the tool, you can download it from the PowerShell gallery. Here you can find the SQLBI push tool 1.0. Now, SQLBI push tool is a commandlet, a PowerShell commandlet, which is only part of the entire tool. The entire tool is published on GitHub, and you can download it from here. It's open source, meaning that if you need any feature, you can implement them by yourself, contributing to the development of the tool. And here you can find the entire documentation that explains you how to work. You have the SQLBI push tool, the commandlet that you can download also from the gallery, but you also have a Power BI push tool, which is a command line to make it easier just to run commands without having to change anything. And you also have an entire .NET library that you can use if you want to embed the code of Power BI push dataset inside your model. And you can find the documentation both on GitHub and on this article that we published on SQLBI that provides you all the details that are needed in order to build the push dataset. This is just an introductory video, so I'm not going to go into all these details. I just want to show you the overall architecture. Anyway, once you have created Model.bim, run it through the tool in order to check that it complies with the limitations, you end up publishing you need to publish the new model. And again, the tools gives you the option of publishing a Model.bim file as a push dataset. So it connects through the REST API for you, and it generates a push dataset starting from Model.bim. It is worth to remember that push datasets do not expose XMLA interfaces. Therefore, because you do not have the XMLA endpoint, you cannot use regular tools. Anyway, once you have your Model.bim and you create your first empty model, you need to start populating it. And populating a push dataset requires you to obey some further limitations, which are not modeling limitations, they are limitations in terms of size. The number of rows that can be stored in a table in a push dataset is smaller than the number of rows that you can store in an import mode. I honestly do not remember all the details, you can find them in the article, but you need to build a model that obeys those limitations. That requires you to reduce the number of rows in the tables. The thing is, it is unlikely you need the entire historical structure. You can reduce, for example, the number of dimensions which are present in your push dataset by avoiding populating them and by reducing the number of tables that you need to load. Moreover, from the fact table point of view, you can reduce the cardinality by pre-aggregating values. It is unlikely you need the details at the product level, at the day level, at the customer level. So you need to build a set of DAX queries that load data from the original data source and populate the push dataset with a smaller number of rows. To do that, you build DAX queries, because DAX is the preferred language to query your import model. And let me show you an example of these DAX queries. I have them here. This is a set of DAX queries that are used to populate the dashboard we have seen earlier. We load the store table, we load the date table doing some rename, because one of the limitations of push dataset is that you cannot use date as a name. That is why we call the new table dates instead of date. So these rename are needed for this reason. And then when it comes to load the sales table, we do not want to load the entire sales table. So we only load the data at the day level, at the store level, and regarding quantity, net price, unit cost, and unit price, we need to compute them pre-aggregating values in such a way that they will still produce the same values. So for quantity, this is simple, we just sum it. But for the net price, we need to compute a fake net price that, when multiplied by quantity, still produces the correct number. This part is important because you want to still run the same code, the same measures, the same queries that you were executing against the original model on top of your push dataset. If you build the data and you pre-aggregate values the right way, you will have the advantage that you do not need to change anything in the code. The tool gives you the option of running this query and update the model. Again, let me show you that. If you run the tool, you see that we have the dashboard, which starts with some data, but while the tool is running, the data is changed and it starts to empty some tables because the tables are first emptied, and then during the execution of the code, some data starts to appear. We end up with a data model that contains the historical data but still has no data for today, because the tool loads the historical data from the original Contoso database in the push dataset, but it is still missing the data of today. Remember that the data of today comes from the OLTP and it is pushed in the data source. At this point, when you have the empty model, or not the empty model, the model with the historical data pre-aggregated with the empty current data, the data of today, you need to start pushing data. And this is where development is needed, because the data needs to be pushed inside the push dataset through REST API, and this requires a developer, somebody that can work either on the OLTP system or on some software that connects to the OLTP system, detects new data, and sends the new data inside the push dataset. But what if you are not a developer and you still want to build a proof of concept? Because maybe you want to show the technology to your boss or to your team in order to investigate whether this is worth doing or not. The SQLBI push tool provides you also the feature to push data inside a push dataset by setting some parameters. It is dummy data, it is not real data, but it gives any user the capability to build a proof of concept that shows how the push dataset works. You need to run a specific command in the tool, providing some arguments, and this starts pushing data in the push dataset. Again, let me show you this. As you see, we start the tool, so we have the dashboard, which is empty. The tool starts, and it starts pushing data inside the push dataset. And the dashboard answers by showing up-to-date information. So numbers are changing while the tool is just sending fake numbers inside the push dataset. This is extremely useful because these steps can be accomplished by any user. You do not need to be a developer in order to build the proof of concept, and you can demonstrate the technology to anybody interested in maybe sponsoring the development of a push dataset. So, as you have seen, using the tool, you have the option of creating a push dataset out of an existing data model, populating it at the beginning of the day with the data of yesterday, and then running a demo that pushes fake data inside the dataset. All this is useful to build a proof of concept. What if you want to build it for real? There you need some developer. You need a developer that is able to create the piece of software that is needed to communicate through the REST API and send information to your push dataset. It's not a lot of work, it's a few days of development, but you need to find a developer with the right set of skills. The advantage of obtaining such an architecture is that you do not have to move the entire solution to DirectQuery. You build two models, the regular import model and the push dataset. The push dataset needs to be created and then updated over time. If you update the original model, you might need to refresh also the push dataset, again using the tools. Now, from the cost and maintenance point of view, there are some important considerations. If you plan to move the entire solution to DirectQuery, then that means you will have a slower model, harder to maintain, and you will need to work closely with the database people in order to make sure that your queries work smoothly. So you pay actually a high price in terms of performance and in terms of the relationship between the original data source and your Power BI model. You will always need to work together in order to obtain good performance. So that is why we do not think that using DirectQuery for such a solution is a good choice. If you go for the push dataset architecture, things are quite different because you need to build your model in import mode without having to worry about performance because Vertipack is super fast. Then you have the additional development time. That is a one-time cost to build the architecture to push data inside the push dataset. After that, you will only have to update your push dataset if any change happens in the original source that requires you to update the real-time dashboard. But to be honest, I think that if you balance these two topics, everything is in favor of the push dataset. As you have seen, this was an introductory video, so I have not been able to explain all the details, but if you are interested in push dataset, you can find the article at SQLBI, where we provide many more information and a walkthrough to learn the details. And if you want to know more about the topic, we also have the Mastering Tabular training, where we explain into greater details all what is needed in order to build push dataset as part of your architecture. If you need a real-time dashboard as part of your entire solution, then my personal opinion is that moving everything to DirectQuery is not your best option, because you are paying a very high price over time in terms of performance and maintenance that you can avoid if you just pair the existing import model with a push dataset. And by using the tools that we introduced in this video, you can actually make it in a simple way. Yes, you have to pay some developer in order to build the overall architecture, but once it is there and it is set, you have a very fast import model for your historical data, and you have a very efficient push dataset that contains the data of today, and you obtain a better architecture that can last for longer. Enjoy push datasets!